And so we're doing number 16. You don't actually have number 16. It's just this page is a part of a larger review packet for the exam. So we're going to start with number 16, so you'll write this on the blank side. So in number 16, they gave us 2 points. D is 7, 3, and D prime is -5, 7. And part A of number 16 says find D prime. So raise your hand if you know what that means. Yeah, Taylor? It means find the distance between D and D prime. Okay, so you have distance formula on a note card, but that formula is D squared equals y2 minus y1 squared plus x2 minus x1 squared. Yeah. Yeah, you can use the note cards on the exam. You can't use note cards on the state test, though. So just be aware that eventually you're going to need to know this formula. All right, so how do I start this off then? Yeah. Good. So the y's are 7 and 3. So it'll be D squared equals 7 minus 3 squared plus and then the x's are -5 and 7. So you do -5 minus 7 squared. And then you subtract 7 minus 3, that comes out to 4. And then -5 minus 7 is -12. Four squared is 16. Then be careful here. Sometimes people square a negative and get a negative. It's supposed to be positive. -12 squared is 144. And watch out. Sometimes people put -144 accidentally. And then 16 plus 144 is 160. And then to get the final answer, you square root. So D is the square root of 160. And then if you have a calculator, you can go ahead and take that square root. But the issue with that is it's a big, long decimal that goes on forever. So it's kind of nasty to write down. So often we just leave it like this, square root 160. If it's a free response question, then definitely leave it like this. If it's multiple choice, then you'll know maybe the choices is a rounded answer and you'll pick the right one. Okay, so that's finding the distance. Now, there was another formula that was kind of like distance. Does anybody remember that formula? Yeah. So there was midpoint as well. Good. Okay, so that's part B. We're going to find the midpoint of the line segment D prime. So what's that formula? What's the midpoint formula? Yeah. Yeah, x2 plus x1 divided by 2. Nice. So x2 plus x1 divided by 2. And then a comma. Nice. So to keep these straight, distance is subtraction, but midpoint is adding. And also, with distance, you do the y's first, but with midpoint, you do the x's first. Again, that's fine. If you have your note card, you can always look that up, but I'm just trying to help you memorize, because it's quicker if you know it without looking it up. So that's one reason to try to remember it. So there's the midpoint formula. So this time we're going to take -5 plus 7 and divide it by 2, and 7 plus 3 and divide it by 2. So -5 plus 7 is 2, and then 2 divided by 2 is 1. And then 7 plus 3 is 10, and 10 divided by 2 is 5. So the midpoint between D and D prime is 1, 5. There was a third formula that was kind of like those. Anybody remember what that one was? Yes? Slope formula, good. So we're going to find the slope. Remember, M stands for slope of the line segment DD prime. And that formula is y2 minus y1 over x2 minus x1. So back to subtraction. Slope is subtraction. Also back to starting with the y's. Y's come first with slope. Okay, so that's 7 minus 3 on top, and -5 minus 7 on the bottom. Seven minus 3 comes out to 4. -5 minus 7 comes out to -12. And then that reduces to -1/3. A positive divided by a negative is negative. So the answer will be negative. And then 4 and 12 reduced to 1/3. So that means the slant of the line that connects D and D prime is this way because it's negative, so it's slanting -1/3. All right, one more part to number 16. So this is find the line of reflection. So D prime is down here, it's -5, 7. And D is up here, it's 7, 3, so we're just making a sketch. And so now they're telling us that D got reflected down to D prime. Hello. Here, have any passes or anything? Okay, yes, thanks for coming. So there's D and there's D prime. And this is getting reflected down to there. So here's the connector line. So where's the reflection line going to be? We're trying to reflect this to there. Where does the reflection line go? Yeah, Judah? It goes through the middle, right? So there's the reflection line. So Judah's exactly right. It's going to reflect through the midpoint, which we already knew from part B, right? That's 1, 5 there. What else happens with the reflection line? Goes through the midpoint. What else does it do? Yeah. Yeah, it's a 90-degree angle, right? So the reflector line is the perpendicular bisector of the connector line. Because it's going through the midpoint and it's making a 90. So it's the perpendicular bisector. Okay, so we got to find the equation of that line. So the equation of the line always comes out y equals mx plus b. So we're looking for the reflection line. So that's y equals mx plus b. And whenever you write the equation of a line, the first thing you need is the slope. So we need the slope of this dashed line. We know the slope of this solid line because we just figured it out. It's negative 1/3. And when you have perpendicular lines, those lines have flipped opposite slopes. So this slope is negative 1/3. So that means the other slope is going to be positive. And then 1/3 flips to 3. So this slope here is 3. Because that's the opposite reciprocal of the negative 1/3. And perpendicular lines have flipped opposite slopes. Everybody doing okay? All right, so now we know the slope of this dashed line, the slope of the dashed line, that's 3. Now we need to figure out the y-intercept. And the way we figured that out is we use the point that the line goes through, which is 1, 5. So you put a 1 in for x, and a 5 in for y, and then you go from there. So that answer comes out to 3x plus 2. Okay, so the purpose of that problem was to review a bunch of stuff. Distance formula, midpoint formula, slope formula, and then also remember perpendicular lines have flipped opposite slopes. So that's why we took the opposite of this and flipped it. All right, so that is number 16 on the review packet. I'm just trying to go through some highlights, some of the harder problems on the review for the exam. Okay, so now flip to the other side, and we're going to look at 49 next. So here's the picture on number 49. And remember we called this an angle chase. So we're going to keep trying to find different letters as we go around. Okay, so let's try to find out A first. Yeah, Judah? 90 degrees, good. So, on your paper, just write A equals 90 somewhere. Yeah, sorry, thank you for reminding me. Appreciate it. All right, so A is 90. So now we're going to go for U next. So here's U. So in order to figure out U, let's look at this triangle here. What kind of a triangle is that? It's an isosceles triangle, right? Because they have that side marked as equal to that side. So when you have an isosceles triangle, it has two equal sides, obviously. That's what isosceles means. But it also means that two of the angles are equal. So this is an isosceles triangle, so that means that this angle is equal to that angle. What do the three angles of a triangle add up to? 180. We already know that one's 90. So 180 minus 90 is 90. So that means these two have to add up to 90. Plus, we just said they were congruent, so that means they're both 45. So U and P are 45. All right, now I'm going to go for S next. This triangle here, what kind of a triangle is that? Yes, Maddie? Equilateral, because see how all three sides are marked as equal? So when you have an equilateral triangle, that means all three angles are equal. So all three angles are 60. So that means S and T are 60. So write down S equals 60 and T equals 60. And also this angle is 60 here. Because all three angles of an equilateral triangle add up to 60. All right, so now we're going to go for N. This is a half rotation. A full rotation is 360, right? So a half rotation is 180. So that means those two angles have to add up to 180. The other reason they add up to 180 is they're a linear pair. So that makes N 120. Everybody see where I'm getting N equal 120? All right, so N is 120. Then we said this one was 60, right? W, what are W in this one called? Vertical angles. And what happens with vertical angles? They're congruent, right? So this one's 60, so W is 60 also. All right, now I'm going to switch gears and go up here to K. What was P? 45, right? And K is vertical with that. See how P and K are across from each other? So K is 45 as well. Is everybody okay with that? Are you sure you're okay with K being 45? Just trying to wake you up. So K is 45. All right, let's go for R next. Where's R? Maybe I don't even have it on this picture. So right here, good. All right, so how can we figure out R? Yeah, Charlie?
I think it's a reflection, but it isn't.
What do you mean by a reflection?
Like H isn't a reflection of R.
Yeah, H and R are vertical.
Yeah.
But I don't think do we have H yet? Not yet, so. We have G, no. We have K. Oh, we have K. K was 45, right?
Yeah.
And then what's this angle? So look at this triangle here. That's an equilateral triangle because all three sides are marked as equal. So that means this angle is 60. And K was 45. So that means this is 105. That's 60, that's 45. So this is 105. And then that makes R 75. Because this is a full half rotation that adds up to 180. This is adding up to 105. So that's adding up to 75. So R is 75, and 8, and Charlie's exactly right, H is vertical with that. So that makes H 75 as well. Okay, looks like I wanted to go for X next. That's down here. How big was T?
60.
So how big is X? Another half rotation, right? So X is 120. G is over here. It's vertical with that one. So it's 60. Make sure you stop me if you get lost. So G is 60. And then finally, we can go up here and find C. Because we have 60 for G. This triangle has to add up to 180.
So C is 30.
Yep, because 90 plus 60 is 150. Subtracting from 180 is 30. Okay, so there's still a few more letters to figure out on that angle chase. So keep working on that, and then when you're done with number 49, go on to 50 and 51, the other problems on this paper. If you run out of problems before the bell rings, I have a few copies of the exam review. So you could work on some more problems while you're here, if you would like. And then the entire exam review is on Google Classroom. So you should do some more of that tonight. Then we'll do some more tomorrow during class. And then